Hello, welcome to the video. I'm going to teach you about which direction a charged particle would be deflected when entering a magnetic field. First of all, magnetic fields that are directed into the page, we use the X symbol for meaning the magnetic field moves into the page. So this is our magnetic field here directed into the page. Okay, a magnetic field directed toward you out of the page, we use the dot symbol. So this bottom one here is the magnetic field directed toward you. So in these two examples above, axis, magnetic field directed into the page, away from you. And the bottom case, the magnetic field directed out of the page and toward you. So let's say we were to place a subparticle, a subatomic particle, a proton, in this magnetic field above here, a positive charge. What would happen? If it's not moving, nothing would happen. There would be no force acting on it. It has to move in order for a force to act on it. So how do we know which way it would be deflected if it were moving, let's say, to the right? So let's say this proton is moving to the right through this magnetic field. Which way would it be deflected? We would need to use the right-hand rule. So I'll show you here. So the thumb here is the first finger. That's the force vector. This vector here, the second finger, is the direction, is the velocity. The third finger here is the magnetic field. So you notice how I'm pointing that inward toward me, okay? And I'm pointing the velocity vector to the right, and I'm pointing the thumb up, so it would be deflected up. The force would be acting up. So what we have to do is we have to orientate this finger here. It has to be pointed toward the right, the direction. And we orientate this one here, this finger here, the magnetic field. I'm pointing it inward. And then the thumb will naturally then point to the deflection, to which way it would be deflected. In this case, it would be deflected up. And so we would then show that this positive charge here, moving right through this magnetic field, directed into the page, would be deflected upward. Okay. Now, what about if the positive charge were then moving through this magnetic field, and again, it was going to the right, like this? Which way would it be deflected? Okay, so this magnetic field is directed outward. This magnetic field is directed out of the page. Okay, it's directed out of the page. So let's see, we got the hand again here, and this time this orientation is wrong because you see this magnetic field, this finger here, the third finger, it's directed inward. It's not directed inward. Magnetic field's directed out of the page. So I had to just flip it around. Let's see. So like this. So you see here the finger here? Now it's directed toward you, out of the page. So I have the magnetic field orientation right out of the page. This finger here, it's directed, it's moving right. That's the pink arrow. It's moving right. The magnetic field is out of the page toward you here. And I have these fingers orientated correctly. And the thumb will naturally then point toward the force, which way the particles be deflected downward. So the force would push it downward. So that means that this one would be deflected downward. So this positive charge moving into a field that's directed toward you, it's moving right, would be deflected downward. Now let's say instead of positive, it were negative. Okay, all we have to do is just invert everything. So let's say it's negative here. Before we had the charge being deflected upward when moving to the right through this field. Now we're going to deflect it up. Since we flipped the charge, it was a positive, now it's a negative, it'll go the other way. Before it was going up, when going through this field that was directed into the page, now it's going to be going down. Okay? we put the negative in this one, negative charge here. Since it was positive, now it's negative. Before it was deflected down, when it was moving right, it was moving right. Before it was deflected down, now it's going to be deflected up, just deflected the opposite way. We could also use the left-hand rule. Instead of using the right hand, use the left hand and do the same thing. Or we can just, whatever we get from the right-hand rule, we just flip it. And all I did is, since the charge changed, I flipped the directions of the force. Okay, so that's how you figure out then which direction a particle will move. A charged particle will move when will be deflected when moving through a magnetic field. Thank you for watching.